All right, get this. What if you could order a data center just like you order a pizza? I know, it sounds crazy, but that's the fascinating concept we're digging into today. And believe it or not, it all started from a sketch on a single piece of paper. It's called the G2 CDCU system, and it basically flips the script on high performance computing, turning it into something that can literally drive right up to your door. I mean, think about traditional data centers for a second. They're these huge, static, incredibly expensive buildings, right? They can take years to plan and build. But what if you need a massive surge of computing power, like right now? Maybe for a big film shoot, or a disaster recovery effort, or some major live event? What if you could just call it in? Well, this is the answer. And the idea is just so brilliantly simple. You're looking at a completely self-contained data center node mounted right on the back of a truck. It's a concept that takes all the power of the cloud and literally puts it on wheels. So, okay, what is this thing, really? This data center on wheels? Let's unpack the G2 Container Data Center Unit, because believe me, it is so much more than just a truck with some servers tossed in the back. First things first, let's get the terminology down. CDCU. It stands for Container Data Center Unit. And that word, container, is absolutely key here. Because by building this whole thing inside a standard shipping container, the entire system becomes modular, easy to swap out, and super easy to transport. But what makes one of these nodes self-sustaining? I mean, what's packed inside that makes it all possible? Let's take a look under the hood, so to speak. And this is the big question, isn't it? You've got to be thinking, hold on, a data center on a truck must have insane power and cooling needs. How on earth does a mobile unit even begin to manage all that? Well, the sketch itself actually gives us a huge clue. See that label, wind/AC cooling? That points to a really clever hybrid system. It could just use the outside air when it's cool enough, and then, boom, kick on the heavy-duty air conditioning only when it absolutely has to. It's all about keeping that powerful hardware from melting down, but efficiently. Okay, and power. What about power? Check it out. The sketch shows dedicated battery modules built right into the system. And honestly, this is a total game changer. It means this CDCU can just roll up to a site, power itself on, and start crunching numbers immediately. It doesn't need to be plugged into the grid right away. It is truly self-sustaining. And of course, you can't have a data center without the actual computers. That's the heart of the whole thing. The drawing shows racks filled with what it calls PC clusters, which is basically just a way of saying groups of really powerful computers all working together. So yeah, we are definitely talking about some serious computational muscle, all neatly organized in standard racks inside that container. So let's just recap for a second. You've got your own power, you've got your own cooling, and you've got racks of servers. It is a complete, self-reliant data center in a box. But the real magic here isn't just about one of these things. It's what happens when you start thinking about a whole fleet of them. Yeah, one node is pretty cool, for sure. But the true power, the big idea, is in the network. So how do you get from a single truck to an entire super powerful on-demand grid? That really is the million-dollar question, right? How do you scale this up? How do you combine the power of all these separate units to create something, well, massive? Turns out the original sketch had a pretty clear vision for that too. Okay, now look at this part of the drawing. It shows what it calls a parking lot, which is basically a pre-wired, ready-to-go grid. The idea is that multiple CDCU trucks can just pull into these special slots, plug in, and bam! Instantly they combine all their computing power into one giant on-site supercomputer. So how do they all talk to each other? The sketch shows two main ways. First, you've got Wi-Fi, which is great for flexibility, for quick connections and getting everything set up. But for the really heavy lifting, for serious data transfer, it connects to a network fiber grid. That's what ensures you get that super high speed, low latency connection between all the nodes and out to the rest of the world. And what this means is that deployment becomes incredibly fast. Think about it. Step 1, a node gets sent out. Step 2, it pulls into a networked spot. Step 3, it connects to the grid. Step 4, its computing power is live and added to the network. Just like that. We're talking about agility on a scale that's just completely new. So all of this, it's leading to a fundamentally new way of thinking about computer infrastructure. We're shifting away from that old, static model to something way more dynamic and flexible. And here is that shift laid out side by side. The traditional way? It's slow, it's stuck in one place, and it costs a fortune up front. But this G2 CDCU system, it's mobile, it's flexible, and it's built around a service-based model. You only pay for the power you use, right when you need it. Honestly, there's probably no better way to describe it than this. It's like an Uber for data centers. That analogy just nails it. It perfectly captures the whole idea. You don't have to own the car anymore, or in this case, the data center. You just summon it exactly when and where you need it. And that right there is the ultimate takeaway. Needing more computing power is no longer about building permits and real estate. It's about logistics. It's about being able to just summon it. Which leaves us with one last really big question to think about. When our most powerful computing tools are no longer tied down to one single place, what new possibilities open up? Think about pop-up research labs in the middle of nowhere, or instant rendering farms for movie sets, or emergency infrastructure after a disaster. When compute becomes truly mobile, what new problems can we finally solve?